Okay, so this video is on impulse, which is the next step after momentum. So we already talked about momentum. It was mass times velocity, but now we're going to talk about impulse. So impulse is a change in momentum created by a force exerted over time. So that means that it's basically a change in momentum. And the way we'll calculate impulse is using this formula up here. So let's go through all the letters and make sure we know what they all stand for. So F is force, like always. So it's in newtons. T is time, and it is in seconds. M is mass. That's still in kilograms. That actually applies to both of these masses. They're the same number for impulse. It's the same mass. Then V2, this means final velocity. And that's still meters per second. So it's V2 because it's the second velocity. And then V1 is initial velocity because it's the first velocity. And it's also meters per second. Okay, so we've got a whole lot of variables going on. So we've already calculated mass times velocity before. And Ft is going to work pretty much the same way. It's just two numbers being multiplied by each other. So, and then you just need to remember that impulse is a change in momentum. So if a problem asks you what is the impulse, it means find the change in momentum. And so you'll need to find, like this Ft, the whole entire Ft, that is the impulse. Ft is the impulse. I should write that down. So this whole side is impulse, this whole side is the change in momentum. Okay, so they have to equal each other. So I want to go through some examples. So there's 4 different cases. We could be solving for the force, we could solve for F, or solve for the time, or the mass, or one of the velocities. The velocities work the same way. So let's go through each of these. Okay, so first force. How much force is required to stop a 60-kilogram person traveling at 30 meters per second in 5 seconds? So this is going to work just like every other situation you've done. I'm going to write the formula again. And make sure you put V2 first, not V1. It's an easy mistake to switch those. So I'm going to go through each of my variables. So F, that's the one I don't know. It said how much force. T, it gave me 5 seconds. It took 5 seconds. Then M, 60 kilograms. And then, so V2, this one's trickier. It says to stop. So if something is stopping, that means it's 0 meters per second at the end. And then it was traveling at 30, or the person was traveling at 30 meters per second. Over here. Okay, so I have all my variables. There's more than we're used to, but we have them all. Now I'm going to go plug them in. So F is what I still don't know. T is 5. Mass is 60. V2 is 0. Mass again is 60. And V1 is 30. So there's a lot of stuff going on here, but I'm going to just simplify. So F times 5, that just stays the same. 60 times 0, that's just 0. That's nice. And then 60 times 30, 1,800. So this means that I really have F times 5 equals negative 1,800. And then to solve this, it's just like F equals ma, the same system. I have to divide by 5 to get F by itself. So F equals 360. And remember that negative. because the negative 1800. And then my units with force are newtons. Okay, so that is how much force is required. Okay, next one, solving for time. So I'm going to do the same thing, write my formula down. Okay, and then identify all your variables. So force, they gave me 550 newtons. Time, that's what I'm solving for. M, 2,000 kilograms. V2, it is now traveling at 20 meters per second, so it's 20 meters per second. And then it started at rest, so that is 0 meters per second for V1. So now that I have all these things, I'm going to go plug them in. Okay, V2, remember to use V2 in the right spot. Mass matches, and then V1 is 0. So again, I'm going to just simplify. 2,000 times 20, that is 40,000. Yep. Minus 0. The zeros are nice. So now, simplify a teeny bit more. And then the way to get t by itself, you have to divide by my 550 here. And we will get that t equals 72.7 seconds. Okay. Next one, solving for the mass. Okay, we've got Ft, write your whole formula. Okay, and then identify all your variables. So F, 15 newtons, T, 5 seconds. M is the one we don't know. We're looking for the mass. V2, I ended at 5 meters per second, so that's V2. And we started at 0, so that's V1. So I'm going to go plug all this stuff in. Alright, so 15 times 5, I want to simplify. That is 75. Mass times 5 minus mass times 0. So the mass times 0, that's just going to go away. 0 times anything, it's just going to go away. So I've got 75 equals mass times 5. And the way to solve for mass, again, is to divide. So I'll end up with 15 kilograms. Okay, next one, solving for a velocity. So, once again, write your formula. Okay, so force, the net force is 100 newtons. Time is 5 seconds. M is 10 kilograms. Let's see, it was initially at rest, so that tells me about V1. V1 is the initial. So V2, what is the speed of the car at the end of those seconds? So V2 is the one I don't know. Alright, so plug everything in. Okay. So let's simplify. So 5 times 100, 500, and then I have 10 times V2. And then my 10 times 0, that's just 0, so I have minus 0 over there. So let me simplify a little bit more. Oops. Get rid of that 0. Okay, and then the way to solve for V2 here, I have to divide by 10. So I will get 50 meters per second is my final velocity, V2. Alright.